Today we'd like to look at the periodic table of elements and notice how it was arranged in rows and columns. First off, rows are also called periods, rows or periods, and they occur down the left-hand side. Here's row number 1, which includes hydrogen and helium. Row 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. And we'll continue down through here with row 3, 4, 5, 6, and 7. Next we want to look at, that was the horizontal lines. Now we want to look at the vertical lines, also known as columns or groups. So in blue we're going across the top. We have column or group 1, which includes hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Row 2. The next section here is called the transition metals. We do not count those in this particular video. We're not going to count those as columns because we're going to use this for bonding later on. So right now we're just going to say that section in the middle, the low section there, is the transition metals. So we're going to skip over to column number 3, which is above boron, aluminum, gallium, indium, thallium, and the next row then is, I'm sorry, not the next row, the next column is column 4, and then we have column 5, 6, 7, and finally 8. So what's the importance of this? What if I asked you, in what row and column is bromine located? So first of all, you have to find bromine. And bromine is over here. It is number 35 on the periodic table of elements. It is Br. Br. So where is that located? Well, it is located in row 4 and column 7. Row 4, column 7. So what's the importance of that? What does that really tell us? So let's look at it. What do we know about bromine? Row 4, column 7. From the little square from the periodic table, we also know that the atomic number is the number of protons and the number of electrons. So it has 35 protons and 35 electrons. The Br is the element symbol. And the atomic mass, which is 79.904, you round it to the nearest whole number. So it basically has 80 as an atomic mass, AMUs. And how do you get that? You take the protons plus the neutrons. So in this case, we have 80 is the mass. We know we have 35 protons, plus how many neutrons would give us 80? That's correct, 45. So over here to the right in yellow and green, I've drawn the nucleus, and the nucleus is going to contain 35 protons and 45 neutrons. And I have them in different colors there, yellow and green, to represent that. So again, 35 protons, 45 neutrons in the nucleus. Now we go to the top here where it says row 4. That tells us there are 4 energy rings around, or orbitals around the nucleus. So here they are, 1, 2, 3, 4 rings. Earlier when we went through, we looked and we found out that each shell or energy level can hold a specific amount of electrons. The first shell can hold 2 electrons, so I have labeled that as 2 over on to the right. The second energy level or shell can hold 8 maximum. The third energy level or shell can hold 18. So right now we have 2 plus 8 plus 18 for a total of 28. Here's the interesting thing. The column 7 at the top is telling us how many electrons are in the outermost ring. 7. So the rows tell you how many rings, and the column number tells you how many electrons are in the outermost ring. So in this case, if we would add up 2 plus 8 plus 18 plus 7, we would get 35 electrons. And by the way, if you look at bromine, bromine's atomic number is 35, which means it has 35 protons and 35 electrons. So I'd like you to use that information now to go and try some of these on your own in the Google form to determine the rows and columns of various elements of the periodic table.